Okay, guys. So you are at Wagnive YouTube channel. So what we are going to study today is inequalities, right? So what are these? How to solve them, etc. We will study today. So first question that comes to our mind after listening or after seeing this topic is, what is this? What are inequalities? It's a topic of mathematics, higher mathematics. So we'll see what is it. So you must have seen equations like, say, x square plus 5x plus 3 is equal to 0, or x minus 1 is equal to 3, or even x square is equal to 64, etc. So all these are basically equality. Why? Because the left hand sides of the term of the equation is practically equal to the right hand side of the equation. Similarly, for this case also, LHS is equal to RHS, and same goes for this and that, etc. So similarly, when when equations look like this, say x square minus 5x plus 3 is, say, less than equal to 0, or x plus 1 is actually greater than equal to 0, or x square minus 1 is less than equal to 0, or even x cube is greater than equal to 0, then these type of equations where LHS is actually not equal to RHS, rather a comparison exists, then this representation form, this form of representation is known as inequality, right? Inequalities are clear. So basically these are you can see these are of four types: one, two, three, four. Like, because LHS is actually less than equal to 0, it can be greater than equal to 0, it can be less than or equal to 0 even also, and it can be greater than equal to 0. When this comparison operators exists, then the equations can be termed as inequality, right? Okay. So next thing. So our main aim would be to solve the equations value that, like, for what values of x square minus 1, what values of x square minus 1 is actually less than equal to 0, or what for what values of x cube is actually less greater than equal to 0. So for that we need to understand two things first, right? The first is the number line. Okay, so what is a number line? So you all might have studied in your previous classes and all that this is the number line. It is represented using a straight line, and it goes from minus infinity to plus infinity. It can consist of infinite numbers, like, say, at the midst of it, it is a zero. Like, from zero, equal number of negative terms are to the left hand side, which is equal to the equal number of terms at the right hand side, right? So what can exist after the zero? Say 1, even 1.5, or even, say, 3.6798, some irrational number also, or on the right hand side minus 1, or say minus root 30, etc. All these terms exist on the number line, with 0 being at the middle of it, right? This is the number line. That's how we represent it. So the second thing to learn to solve the inequalities would be the intervals, right? What are intervals? Okay. So we will learn intervals by just taking examples that need to be considered. Say such that we have an example so that x belongs to minus 1 to 2. Okay, close brackets. That means on the number line, suppose we draw the number line minus infinity to infinity, 0 being in the middle of it. It doesn't matter, like, you can place 0 here also. It does not matter that if it is meant to be in the middle or something, but it's just like, for a reference, we take 0 at middle, right? So minus 1 would be somewhere here, 1 would be here, 2 would be here, 3 would be here, minus 2 would be here, etc., right? So the interval x belongs to minus 1 to 2 simply means that x is a variable that can exist anywhere between minus 1 to 2, right? So this is the basic meaning of this interval. Okay, so we can take another example also, like this. You can see that this is These are closed brackets. So what the next term is should be like what are closed brackets and open brackets. So we just take another example, such that let's say x belongs to 0 to 3. Okay, and this time all these brackets are open brackets. That means on the number line we represent all these numbers starting with 0, 1, 2, 3, 4, -1, etc. Okay, so on the number line x belongs to 0 to 3 open simply means that x can be any number between 0 to 3 such that these two ends are not included, right? So this is the basic literal meaning of these closed and open brackets. So we can take another example. Let's say for your understanding, you can take another example like let's say x belongs to -1 to 5. Okay, this time here it is open and this time it is closed. So you can pause the video and like solve it for yourself and just check it that on what interval x lies. So we can show that this is 0, this is -1, and somewhere it would be 5. So here it would be -2, it would be 6. So x can lie between -1 to 5. Note that the left hand side bracket of this interval is open. So here it would be open and here it would be closed. So x can lie anywhere between -1 to 5 such that only 5 is included, right? So now we have understood both the things. For understanding inequalities, what are these? Let's have a quick recap. The first one is the number line. The first one is the number line. The second one is the intervals, right? Now, number line is a basic straight line and intervals are ranges to which x can vary. Then, so now we'll quickly jump into what are inequalities. Okay. Okay. So again, for solving inequalities, we are allowed like we need to understand, we need to go through these three steps. Okay, just have a look at it. We'll discuss. So step one is like for a given fx, find its roots. Okay, what are roots? Roots are the values of the function at which fx goes to 0. Okay, so we'll see what this means. Step one is this. This is step two. What is step two? Step two is generate number line with roots of fx. Then, and step 3 would be finding the sign scheme of fx. We will see all these three steps one by one, right? So we'll just take an example to start. So let's say we have any example we can take. Suppose we take this example as first example. Uh, find find the range like for find the interval for which x square minus what we can say, let's take 2x square minus 2x plus 2 is equal to 0. Or we may also take some format such that the roots can be calculated easily for the first step, for the first example. Okay, so this is equality. We need to find such that x is less than equal to 0. Okay, so what are the steps? We will go to solution, and as we have learned, these are the steps. The first step is to find the roots. Okay, so finding the roots, we'll use the quadratic formula we can use. So what quadratic formula says that x is equal to -b plus minus b square minus 4ac by 2a. Okay, so x would be minus b. We'll put 3 plus minus b square 9 minus 4 to the 8 by 2a, 2 into 1. Okay, so 9 minus 8 would be 1, and square root of 1 would be 1 itself. 3 plus 1 by 2, that is 3 plus 1 by 2, and 3 minus 1 by 2, that is 2, and it would be 1. Okay, so we can write it as, we have to find x such that x minus 1 and x minus 2 is less than 0. Why this? Because if it's such that, let's say a is a factor and b is a root of, a and b are roots of fx, then fx can be written as x minus a, x minus b. Okay, this is simple mathematical factorization. So if a is 2, we can substitute it as x minus 2 and x minus b as x minus 2. This is fx. I just rearrange it and wrote it like this, x minus 1, x minus 2. Okay, step 1 done. The roots are 1 and 2. Okay, so this is the step 1. What is step 2? Step 2 is like, we'll see, it's actually generating the number lines, right? Yeah, generating number lines with roots of fx. Okay, so we'll generate the number line. This is the number line, and we'll just put the roots of the equation as a base point. What are the roots? 1 and 2. We'll put it here, 1 and 2. Done. So what this step actually does is that it divides the entire number line into n plus 1 regions, n plus 1 intervals, where what is n? N is the number of roots, so that we can see there are 2 roots, so it divides the region into 3, n plus 1, that is 3 regions, 3 intervals, like minus infinity to 1, 1 to 2, 2 to infinity. Then, and what is step 3? Step 3 is, see, finding the sign scheme of the fx. Okay, so what is sign scheme? Sign scheme is nothing but first we write fx. Fx is equal to x minus 1 x2, right? So this is fx, we have seen. This, right? Okay, so one more thing, so sign scheme of fx, we actually write sign scheme of fx simply, but not fx equal to 0 or less than equal to 0 or greater than equal to 0, nothing. We just write this sign scheme of fx. So we write like this only. What I'm trying to say, the sign scheme of fx is, that's it. We don't write sign scheme of fx less than 0 or fx greater than 0. No, this is wrong. That's it. We write like this. So next step. So what is sign scheme? Sign scheme is nothing but the classification of regions of this number line as negatives or positives. Right? Simple. Just simple. Okay. So it is 1, it is 2. Okay. So this, it is just simple, the minus plus allocation of fx. What is this? So we can take, just look at this step, this expression. So we can start by this region. So take any number that lies between 2 to infinity. We can take, say, 3, 4, 5, 6, or something like that. It would be better if you can take some easier numbers, so that you just have to calculate the signs, right? So we suppose we take 3. Okay, so at region 2 to infinity. Okay, uh, let's say we are talking about x is equal to 3. X is equal to 3. Then f3, what is it? We calculate. It would be 3 minus 1 into 3 minus 2. Note that you don't have to calculate the value, just have to know the sign. So 3 minus 1 is 2, which is positive, and 3 minus 2 is again 1, that is positive. Plus into plus, that is plus. Okay, that means the sign scheme of fx in the region 2 to infinity is positive. Okay, Again, we check for, say, a region between 1 and 2. Okay, so say this is 1, this is 2, at region 1 to 2, say x is equal to 1.5. Okay, so fx would be f at x would be f at 1.5, and fx was this, right? Fx was this, x minus 1, x minus 2. Okay, so we will put 1.5 here, 1.5 minus 1 into 1.5 minus 2. Okay, this is positive, but this is negative, hence plus minus minus. So the sign scheme of fx in the interval 1 to 2 would be negative. And again, we can take for the final part of our step, we can take region minus infinity to 1. We can take 0, 0 pe we will check. So 1.5 is a 0 minus 1 into 0 minus 2. It would be negative, again it would be negative, 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 positive. Okay, so this is positive. So the final, so what we write, actually in exam papers and all, you don't need to write these things, right? You just need to write the steps that we have written, like you can include all these steps, this, but you can actually just find the science thing directly. This you had to do it mentally, these things. Okay, we'll learn. Okay, so what you will write finally, you will write in exam papers or anywhere that the sign scheme of fx is, right? So it will draw the number line, you'll draw it roots 1 and 2. Okay, and you will denote all the minus positive that we just found out. This would be plus, this would be plus, this would be minus. So this is the sign scheme. Then our assessment part is done. So what our question was asking? Our question was asking this. It is find the interval for which fx is less than equal to less than 0. Okay. So our assessment part is done. So we will, what we'll do, we will just conclude our answer that fx is equal to x minus 1, x minus 2, or given x square minus 3x plus 2 is less than 0 for x belonging to where the function goes negative. For this to this part, right? So x will be 1 to 2. So this is our answer. This is our final answer. Suppose they had asked like uh, for what interval fx is actually less than equal to 0. Okay, so what is the difference between these two? So you can see that only less than part is there, but here less than equal to part is also there. So you'll just replace these two brackets, these two open brackets, by these two closed brackets, right? Done. And suppose let's, for your assessment, let's ask like for what, this is question 2, this is question 1. Suppose they had asked for what values of fx, this for what values of x, for what values of x fx is actually greater than equal to 0. So what you would write, you see that x is positive for this region, also for this region. See now, right? Like here it is positive, here it is positive. So you'll finally write answer would be x belonging to minus infinity to 1 close brackets union 2 to infinity. Why I have written close brackets at 1 and 2? Because equal to sign exists at the question. So hence our question is solved. Note that at infinity, whatever the question might be, the brackets always used are these open brackets, because infinite is not a Infinity is not a finite number. You cannot like just use the capital brackets are there, right? So this is our question. Okay. So let's take another example, like what we can take. This our basically our theory has part has been done. So you have learned all the details about intervals and all this inequalities and all. So just for our understanding, we will take example number two. Okay. So find we can say find x for which fx is equal to x minus 2 square x minus 3 is greater than equal to 0, right? Okay. Again, we'll follow the same steps. We'll find the roots. So this question actually has been made easier for us. Why? Because the roots are already given to us. How? Because you see that these are already in factorized format. What we were doing in the last question, we had this question, right? X square minus 3x plus 2. We finally wrote it as x minus 1, x minus 2. It was less than 0, right? Okay, less than 0. Okay, so what we did just like this. We factorized it and wrote it as a product, wrote it as a product form. So it has been already given to us in this question. Okay, so the roots given to us are x is equal to 2. Again, since it's a quadratic function, so there is a double root. X is equal to 2, 2, and 3. Okay, so these are the roots. Root is done. Second is generating number line. Number line we will do. We will make infinity to infinity, and then place the roots at there. 2 and 3. We don't need to write double twice this 2, because number line we can skip that, right? Because anyway there is a only one fixed place for 2. Okay, creating number line. And third, what we have to do, sign scheme of fx. This is the most important part of our inequality question solving, and actually it is also the most easiest part also, right? The sign scheme of fx, we have fx as x minus 2 square x minus 3. Okay, and we have to find fx so that should be greater than or equal to 0. This is our question. So we draw the number line, we points minus infinity and plus infinity here. We write the roots as this, and we check at these three intervals, like minus infinity to 2, 2 to 3, and 3 to infinity. Okay, so you don't need to write this time, but like since we are just starting, we can, for our own use only, we can use this. So let's check for region 3 to infinity. Okay, so let's take any number, say x is equal to 4, then f4 would be, just put these values here. So 4 minus 2 square into 4 minus 3, that would be 4 minus 2, 2 square, 4 into 1. That is positive. Remember, you don't have to actually calculate the exact value, just need to know the sign. So it is positive here. Okay. Again, for this second, let's say 2.5. We can check at interval 2 to 3, 2.5. So 2.5 minus 2 square into 2.5 minus 3. This is square, anyway it would be positive, and 2.5 minus 3, it would be negative. So it is negative, right? Again, for third, let's say minus infinity 2, we can check at 0. So this is what, 2, 3. Okay, so 0 minus 2 square into 0 minus 3. This is square, this is anyway negative, positive, I'm sorry. And this is 0 minus 3, that is minus 3, that is negative. It is negative. Okay. So the sign scheme would become for fx would be, this is the number line, 2, 3, what is it? It is positive, it is negative, and it is negative. Just drop it. Okay. So this is a sign scheme, or what our this so basically our assessment part is over. So time for final answer. So final answer was will be like we had been asked for what values of fx is greater than equal to 0. So we will just write x belonging to 3 to infinity such that 3 is under big brackets. Why 3 is under big brackets? Because in question they have asked greater than or equal to. Again, like now you guys tell me that if fx would have been less than 0, then what would be the answer? Less than equal to 0. It would be yes, you're right. Even if you want to write something on your paper, you can pause the video and just check with the answer that we are going to write. Okay. So x would be minus infinity to 2, okay, union 2 to 3. Okay. Or we can simply write is that x belonging to minus infinity to 3. Okay. This also, with brackets minus infinity to 3. Right. Why big brackets? Again, because equal to sign is also there. So this is our question number 1, sub question 1 is sub question 2. And finally, if someone had asked like for what values of x, such that find values of x for which fx is less than 0, right? So the difference between this and last question is simply we can write again fx less than 0 implies that x belongs to minus infinity to 3, but there would be just open brackets at this end because no equality symbol there. So that's it for the video. Like I hope you have learned something that would help you in the future or anywhere in your exams or something. So if you have any doubts, you can just put right in the comment section and we'll see next. Okay. Thank you and have a nice day.